In this 7th lecture of special relativity, we discuss the Michelson-Morley experiment, a fundamental experiment for the theory of special relativity. But first, we explain that light is nothing but an electromagnetic wave which obeys Maxwell's equation. For simplicity, we considered Maxwell's equations in the vacuum. That is, when assuming no charges and no currents, the equations can be manipulated in order to show that both the electric field E and the magnetic field B propagate according to the linear wave equation. We explain then the concept of luminiferous ether, an invisible medium that scientists introduced to allow light to propagate in the vacuum. This introduction posed huge problems, as it seems to suggest that the frame of reference where ether is at rest was the preferential one. Michelson and Morley devised their experiment to measure the ether wind, that is, the velocity that exists between the Earth moving and the ether that is at rest. Their experiment was an interferometry type of experiment. Interferometers are setups able to relate changes in the distances or times to changes in the interference patterns. The idea of Michelson and Morley was to measure the changes in the patterns due to the speed and the direction of the ether wind, v. In particular, they estimated the time difference, delta t, between two light signals passing through the interferometer versus the ether wind speed. The beauty of their experiment was that it could completely rotate on itself, so that a different time interval following a rotation of 90 degrees should be observed. The difference in the time intervals could then be associated to a shift delta in the interference pattern. The unexpected and amazing result obtained by Michelson and Morley was that the shift they measured was always zero, no matter how they rotate the apparatus. This meant that the entire hypothesis of the ether wind, and as a consequence of ether itself, was completely wrong.